Okay, all right, so let me just talk a little bit about this week and the finals and whatnot. So our final is scheduled for Wednesday of next week, right? Okay, everybody should have that at least marked in their calendar. So Wednesday at like, what is it, 8 a.m., 8:30, something like that, right? Or I don't remember. Okay, I'll have to check myself. Huh? Huh? 8 a.m. Wednesday, is that what it is? Yeah, I think so, okay? So, get plenty of sleep, anyway. And so this week we'll spend kind of reviewing, just making sure, I don't know, all of these little nitty-gritty details about confidence intervals and hypothesis testing and statistical inference, all of this is squared away so that when you move on in life and someone asks you what a p-value is, you will make me proud and and give them the correct definition of the p-value, that it's the probability of the data if we assume that the null hypothesis is true. So anyway, I thought we would spend time reviewing that. I am aware that I still need to publish the answers for the Chapter 9 homework. And other than that, that should be it. I think last week I said I would cover a few sections from Chapter 12, but it was brought to my attention that your textbook doesn't even have a Chapter 12 in it. So we won't do Chapter 12. So, okay. So how far does your textbook go? It just ends in 9. Oh, so we covered our whole textbook. Oh, well, good for us. Okay, so, all right, well, great. Okay, so we covered through Chapter 9, and we can spend the rest of our time just reviewing and making sure everything's okay. All right, any pressing questions or concerns before we continue on? We're good? Okay, so then, okay, so I guess I'll start my recap of the course, and as we go along the way, if you have questions, raise your hand and we'll talk. Okay, so, all right, yes. Okay, so let's a review of statistics. Okay, so let me just kind of illustrate where we've been in the course and where we are, and we'll get into the in-depth stuff. Okay, so kind of our big picture idea. Okay, and if you ask other people what statistics is all about, they might give you different definitions, and that's fine, right? How do you define what beauty is? I don't know, right? So this is my definition of statistics, which is beautiful. Okay, so our big picture idea. Okay, so I'd say statistics, or the study of statistics, allow us to make conclusions, okay, implicitly about a population with limited data, okay? And this in turn statistics helps us to understand the world around us, right? All of our subjects that we study. Okay, and so again, the population would be everyone too big for us to the population is everyone related to the question that we are trying to answer. This is too big for us to observe directly. Okay. So instead, we study a sample, and based on the sample, we try to understand the population. So this is stats 10. Anybody gonna travel over spring break? Go home. Okay. I was hoping for a more exciting answer. Okay. Huh? You're boring? No one is boring. You live in Los Angeles right now. This is like the greatest city ever. And you're at like the greatest school ever, so you can't complain about being boring. Okay. All right, so based on this, we're trying to make conclusions about the population. Okay. All right, so for our conclusions to be valid, based on the sample to be valid, our sample must be representative of the population. Okay. How do we get representative samples of the population? Well, the truth is that it's really hard to get representative samples of the population. We have different ways. One method that should give us representative samples, but is not guaranteed to do so, is simple random sampling, okay? So one method that should give representative samples okay, but it's not guaranteed. Simple random sample. Okay, and assuming that we have a representative sample or a sample obtained via random sampling, okay, we can apply our understanding of probability, sampling distributions, and whatnot to then make conclusions about the population, okay? probability and sampling distributions, and which I guess the normal model too. Okay. Okay, so kind of our concept overview. So in week 1, no, I don't want to do it that way. We started off with kind of descriptive statistics. Okay, and we spent a decent amount of time talking about descriptive statistics. Topics that fall under descriptive statistics would be things like numeric summaries, so we covered numeric summaries for center and variation. Okay, and numeric summaries also for relationships between variables. Okay, so what are the numeric summaries that we have for center? Mean and median. And the numeric summaries that we have for variation, oh, I guess I used to call it spread. Same thing. Numeric summaries for spread or variation would be IQR, range, and standard deviation. Great. Okay. And numeric summaries for relationships. What's that? R, correlation, right? Okay, and then we could formalize that with like linear regression equations also. Okay, and so these were all just ways to kind of summarize our data with using just a few numbers. So we could take a bunch of numbers, summarize it with just a few descriptive things. So we had numeric summaries, and then we also had just like describing distributions with the shape of the describing the shape. Okay. All right. So we had descriptive statistics, and then we covered probability rules. And then kind of evolving from our probability rules, so things like and or, we learned about those rules, and then mutually exclusive. But really the important one was this concept of independence. Once we learned those rules, out of that developed probability distributions. Okay, and I think we were able to kind of develop how a binomial distribution could arise out of our probability rules, right? We just said, you know, multiply the probability of a success and raise it to the X power because you need that many successes, and that means you're going to have this many failures, and you need to raise that power to, or you would have this probability of failure, and you need to raise it to, you know, the number of failures you have and how many different combinations. So the binomial distribution, I think we could relatively explain straightforward out of our probability rules. The normal distribution is a little bit more complicated, but we just said, hey, use this table, it works, okay? If you decide to study statistics further here at UCLA, you'll have to take a mathematical statistics course, which will kind of show you how the normal distribution is derived and things like that. And it involves calculus, so it's a little bit more complicated. But anyway, we've developed probability distributions, okay? And we took our understanding of probability distributions and kind of this, we looked at sampling distributions, okay? So we said, hey, what happens if you repeatedly take samples out of a population? Okay. Okay, and that gives us sampling distributions, okay? So now that we have an understanding of sampling distributions, and we have kind of how descriptive statistics work, these two things, we can kind of say, hey, here's the data, it's summarized by these descriptive statistics. My understanding of sampling distribution says this is the kind of the probability of our data. We arrive at kind of p-values, okay, or probability of our data, statistical inference, okay? So we get, you know, p-values and hypothesis tests. As well as confidence intervals. Okay, and then, you know, we have basically, what do we have? We got a bunch of these things, like 7 of these topics, okay? We got confidence interval for P. We have a hypothesis test for P, and we have a hypothesis test for P1 equal to P2. We also have confidence interval for mu, hypothesis test for mu, confidence interval for mu1 minus mu2, or I'm sorry, mu1 equal to mu2. No, sorry, it is mu1 minus mu2. I don't know what I'm saying. And then a hypothesis test for mu1 equal to mu2. So we did skip. There's something missing here, and that's like we skipped the confidence interval for P1 minus P2, okay? I don't feel like we're missing out too much by skipping that topic, and I'm sure for the motivated student, you could read that section and pick it up quite easily. It's just a matter of different formulas here. Okay, so I will be, you know, I'm providing you the formula sheet so you don't have to worry about trying to memorize all of these standard error things and test statistic things for all of these different things, okay? The important thing is knowing when to use each kind of test, okay? So let's talk about that. Okay. All right. So when will I use which each inference method? Okay. So generally in questions, you would use a hypothesis test to generally test a claim. Okay. Whereas you would use a confidence interval to kind of make a statement about a population parameter. Now, the truth is in many situations you can use a confidence interval or you could use a hypothesis test, and either of them would be valid. Okay, so I guess just look out for keywords. You know, keywords to look out for. In questions. All right, so if you see confidence level somewhere in there, you're going to be doing a confidence interval, right? Okay, so keywords for we'll say confidence intervals. Okay, so you'll say you'll see things like confidence level, maybe kind of what are some plausible values of blank. So because here, you know, plausible values of the parameter, I would say kind of those are the, you know, the key things there. Okay, as far as hypothesis tests go, if you see anything about a significance level, then you're going to be doing a hypothesis test. If you see things like a test statistic somewhere in there, then that will indicate a hypothesis test as well. Okay, and of course, if there's anything about what are the correct hypotheses, obviously a hypothesis test as well. Okay, you're going to see words like standard error and words like do we have evidence. Those are going to be common to both confidence intervals and hypothesis tests, so you can't use those as ways to distinguish whether you should use a confidence interval or a hypothesis test. Okay, so but you know, test statistic, hypothesis, significance level, these will only appear for hypothesis test questions, confidence level, and plausible values of the parameter. This will be parameter, whatever parameter it is that you're looking for. That will be for confidence intervals. Okay. Okay. Are you dealing with means? So if so, the next part you've got to decide: are you making a is your parameter mu or is your parameter p? Okay. Parameter mu or p. Okay. All right. So if you have a numeric variable, you'll be dealing with mu. Okay. So keywords somewhere in your in the problem, you'll see things like a mean or sample average, or you know, something along the lines of sample average. And if you see something about a sample standard deviation, those are all indicators that you're dealing with a numeric variable. Okay, so if in the problem description it talks about, your data has this average or this mean, and it has this standard deviation, those are very strong indicators that you're dealing with a mean. Okay. Okay, if you have a categorical variable, you'll be dealing with proportion. Okay. So keywords will be there will be a count. Okay, counts. I mean, it won't say count, but it'll say, this many people had this trait. Okay, counts. Keywords, so counts, or this many people had this trait. That's a good indicator of a categorical variable. Okay, Okay. It is possible for percentages and proportions to be actually numeric variables. Most of the time, I'd say 99% of the time, if it says something of, well, okay, so a sample proportion will be a key, clear indicator that you've got a categorical variable. Okay. However, if you get something, I'd say almost always, but sometimes there are exceptions, will be things like percentages. Okay, so percentages, if they are percentages of a categorical variable, then that works, but it could be, a percentage could be a numeric variable. So for example, if we were talking about test scores, your test scores are generally percentages, right? You'll say somebody scored at 80% and someone else scored at 90%. And we could talk about the class average test score being 87%, okay? In that case, because you have an average test score, that would be a numeric variable. So percentages, if it says, 80% of the class, I don't know, is from the state of California or something like that, then that would be a categorical variable. But it is possible for percentages to be treated as numeric variables. So you just have to read carefully. But if it talks about a sample proportion, then that will be a categorical variable. But almost always percentages will be categorical variable, but percentages could also be numeric variables. So let's just say careful. Percentages could be numeric variables. Okay. And then one sample or two. This is pretty clear, but sometimes it's not, okay? One sample or two samples. All right. See how many ends you can identify. Okay, so if there's only one n, you only have one sample. And if you can identify two n's, then you've got two samples. So I mean, that seems obvious, but sometimes problems can be written a little bit tricky, I guess is the right word to say there. And it might seem like there's two samples, but there's really only one, or whatnot. Okay. All right. So let's. I'll just kind of write up some fake scenarios here. And you tell me which scenario we've got going on, okay? So for all of these, So you can pull out your clickers here. Okay, so oops, that's not wrong. Okay. All right, so your answer choices will be 1 sample means, 2 sample means, okay. 1 sample proportions, 2 sample proportions. Why is there a... Okay, I don't know what happened. Sure. It's gonna... Okay, and then, you know, we'll just assume that the problem will indicate whether or not you got to use a hypothesis test or confidence interval. Where's my... Here it is. Okay, so we'll say a researcher wants to know if the rate of teen pregnancy has changed. Okay, so in 1995, the rate was found to be, I have no idea what, I'm making up. Okay, I have no idea. Okay, and a recent study surveyed 100 random teenagers, I should say female, and found that 100 I don't know. Okay. All right. So, which method is appropriate for this? Okay. Oops, what's going on here? What? Oh, okay. Okay, all right, so now you can start clicking. Okay, looks like most of you guys got your clicks in, so I'll go ahead and stop this. Okay, so let's so for this one, okay, the correct answer is answer C. Okay. All right, so let's talk about that. And so, you know, those of you, all right, so here we're talking about teen pregnancies, okay? So this is a categorical variable. Either someone had a teen pregnancy or someone did not, okay? So this is a categorical variable. Okay. And you know, key things is that, you know, we're counting how many, right? So, we counted 103 teen pregnancies in our sample. Okay, so this is another indicator that it's a categorical variable, right? Okay, so that means we're dealing with proportions. Okay, so now the question is, do we have one sample or do we have two samples? Okay, so when we're looking here, it looks like it says in 1995, so this is a year, the rate was found to be 8%, okay? Yes, this had to be established via some kind of sampling method, but that information is not available to us, okay? So we do not have an n associated with this value, okay? So there's no n, no sample size, no n or sample size associated with this value, okay? So, it was, the rate was found to be 8%, but we don't have an n associated with this. So we don't know exactly how much weight we can kind of assign to this thing. So we really only have one n available to us, and that's this number 1200. So only one n, one sample size, one n equal to 1200 is available to us. Okay, so because of that, we only have one sample that we can use in our calculation methods here. All right, is that okay? If I had said in 1995 there was a survey of 1,200 students or 1,200 teenagers to find the teenage pregnancy rate, then you would have two n's, okay? But because that information is not provided to you, we cannot assume anything about the size of the sample used to obtain this number. Okay, so therefore, we only have one sample available to us. Are there any questions on this? Okay, so this one would be one sample proportions. Okay, let's try another. Okay. So, okay. A teacher wishes to know if the performance of his students has changed between quarters. Okay. Last quarter, there were 150 students in his class. The average grade was 87% with a standard deviation of 12%. This quarter, the average grade is 90% with a standard deviation of 10%. For his class of 160 students. Okay, so go ahead and, oh, where did my thing go? Okay. Okay, so again, yeah, choose which analysis method is appropriate for Okay, I'm going to go ahead and click stop here. Okay, let's see what we got. Okay, indeed, that is the correct answer. Okay, some of you guys picked proportions and some of you guys picked one sample means. Let's see here. Okay, so so the correct answer here is 2 sample means. Okay, so as we're going through, we have n1. We have a sample size associated to the first class and a sample size of n2 equal to 160. So we know we have 2 samples. Okay. And so here, we're accustomed to seeing things, percentages generally being associated with proportions, but if we look at it, we see things like the average grade being a percentage, and we also see standard deviation being a percentage. Okay, so the fact that an average appears, okay, and a standard deviation appears in as part of our data indicates that we are dealing with a numeric variable. Okay, so average and standard deviation indicate that we're dealing with a numeric variable, so we use means and not proportions. Okay. Okay. So it's very important, as well, not just for the sake of the final exam, but after finishing this class, I don't know how much statistics you'll encounter, but in order to kind of think clearly about the inference method that we're going to use, it's very important that we recognize, are we talking about proportions here, or are we talking about means? Okay, are we dealing with a numeric or a categorical variable? Because the inference methods are very different. Okay, I mean, it's a matter of just choosing different formulas and things like that, but if you try to use the wrong set of formulas for whatever we're talking about, it'll be a sad day for you. Okay, so please make sure we can distinguish between each of these types here. I think we'll end here for today. We'll continue talking about inference on Wednesday and Friday, and I'll be sure to get the solutions for Chapter 9 posted as well. Okay, so we'll see you guys in a bit.